Hi, everybody. Welcome to another Chats with Children. Today is a different Chats with Children because I'm delighted to be joined by Mark Lorch, who is Professor of Science Communication and Chemistry at the University of Hull. And the reason we're having the chat today is Mark actually published recently an article on the Conversation website called Covid-19, Kids Are Using Soft Drinks to Fake Positive Tests. I've worked out the science and how to spot it. So I saw that article and I put it on LinkedIn actually, and I shared it on LinkedIn, and he had quite a few people viewing it and liking it. I thought, well, actually, this is such an interesting story. I'll get in touch with the author and find out a bit more about it. So I've got in touch with Mark, and he's been kind enough to spare me some time to just talk about the article and some other issues around COVID. So Mark, lovely to meet you. How are you?
I'm well, thanks. Yeah, good to be here as well. Good to be chatting to you.
Fantastic. And so you're based in Hull. What's the weather like? Is it nice and sunny? Because it's a bit
Yeah,
mixed
it's all right. It's all
weather
right,
down in
actually.
the south.
Yeah, it's all right. It's quite warm and pleasant at the moment. Hay fever's doing me, not so great, but otherwise quite a pleasant day.
It's a double-edged sword, isn't it? The sun comes out, but all the hay fever sufferers then start to get worse. But
Exactly.
anyway, before we start talking about your actual article, would you mind giving viewers a quick overview of your background and role?
Yeah, so I'm a biochemist by training. So actually, did my PhD on a subject called protein folding, which is how protein molecules get from the long extended strands that they are as they're produced, these long polymer molecules, and how they then fold up into the perfect three-dimensional shapes that they have to adopt to do their job correctly. And actually that relates quite nicely to what I'm going to talk about later about the antibodies on the lateral flow tests. And then anyway, but then after so I studied protein folding both as a PhD and some of my postdocs, and then some years ago I came to the University of Hull and studied interactions of molecules at lipid membranes and so on, and have from there diverged into all sorts of other things, including most recently actually citizen science-based chemistry. So using these little devices here, which are devices, paper analytic devices that change color in the presence of pollutants in waterways. So there's a
Right. Okay.
we've got a mobile app that allows people to record the data from these. We send them out to people, and then they report the data back to us. And then, as well as the sort of chemistry and biochemistry teaching and research, at the moment I'm also the head of department for chemistry and chemical engineering here at the University of Hull. And my other hat is as you mentioned earlier, I'm Professor of Science Communication, which means that I get to go out and speak to people about science that I love, write about it and so on, and occasionally get accused of being the professor of mucking about as well. But I'll take
that. I think anyone who works in communications is a
yeah,
professor of mucking about as well.
yeah,
So
that's right.
Right. Well, that's brilliant. Well, thank you for giving me that overview. Actually, before we talk about your article, there's a couple of things and just about your role at the university
Yeah.
and talking about both the teaching of chemistry at university and also how COVID has impacted the learning at university. There's been a lot of talk obviously of students now having to do a lot of remote learning and so on. So how has it impacted you teaching a subject like chemistry at university, the pandemic?
Oh well, I mean, it's been really tough, I mean, as it has for everybody. I feel dreadfully sorry for the students who wanted to come and spend time on campus, have that whole student experience, and have had to put that all on hold. It's been really tough also for the staff, because of course we've had to put all our teaching online, and a lot of the academic staff have really risen to that occasion. We've got some wonderful online content now, and of course future students are then absolutely going to benefit from that, because they're going to have the face-to-face contact with us that you would normally expect, plus all that extra online content to enhance that experience. But the thing that we've really missed in the last year is all the practical work. Chemistry, biochemistry, chemical engineering, it's all very, very hands-on subjects. We would normally expect to spend a day a week in the lab with our students, or every student would expect, in fact, we spend a day a week in the lab, and most of that has gone, and so we've got plans now for lots of catch-up sessions for next year and so on, but because that practical work is such an important part of learning how to do chemistry. It's where you really apply all that knowledge that you learn in the lectures and tutorials and the videos and so on.
Sure.
So hopefully we can all catch all that up again. But yeah, it's been a real shame, and something we really miss. I mean, that's the bit where, that's the thing that most of us really like as chemists, is being in the lab, making things.
Sure. I mean, hearing you say that, so one question comes to my head though, is that for those people who are, for example, in their final year this year, I mean, do you think the lack of doing that practical learning, if you like, and those experiments will have an impact in terms of their employability going forward?
Well, actually, I mean, the final year students were at least allowed back to complete some much of their projects. So whilst they did lose some time, they were one of the groups that was allowed back to complete practical work. So many of them have had some have had reasonable lab experience. It's not quite the same amount that they would have done, but at least some. It's going to have affected their experience, but then at the same time they have learned other skills. It's not like with the project work that they've not done anything. They've gone and learned other skills. Sometimes it's about data analysis and data mining. Sometimes it's been actually much more about having much more time to spend looking in depth into the literature and so on, and so there are other skills that they could that are useful that they have learned, even if it isn't the ones maybe they wanted to do.
No, that's a fair point. And I suppose also a lot of companies now and researchers, they've had to work remotely, and there's been a lot of remote learning for people in industry, let alone in academia. So there is that as well. So and one other question is that, again, with the pandemic, science has come to the fore, especially with the vaccine development and so on. And I think the general public have learned more about science than ever before. So do you think that's had a positive impact in terms of people wanting to do subjects like chemistry and science now at university?
It's certainly had a positive impact on some areas of science. I think the biomedical areas have seen a big increase in this. Unfortunately, not chemistry, actually, which is a real shame, because chemistry has actually underpinned massive amounts of the way that we've had to tackle the COVID crisis. For a great example is the Pfizer BioNTech vaccine, which is is RNA encased in particles that allow you to deliver the genetic material to the cells. That's all, that's chemistry there. And building and materials from the chemistry, building that vaccine. It's really new, innovative vaccine, and it's all, it's fundamentally chemistry. And sometimes I get a bit annoyed, because sometimes the chemistry in these things, not just in the vaccines but other areas of science, gets forgotten. Wonderful other examples, the other end of the spectrum, and is things like the Mars rover. I think the physicists and the engineers get so much credit for that. And what is the Mars rover? Well, it's a mobile analytical chemistry lab, that they've landed on the and all of that. I think that sometimes gets overlooked. I don't know. We grumble about that a lot as chemists, physicists nicking our subject. But we need to tell people about it a bit better, don't we?
No, it's all down to science communication, isn't it? So there we go. Right. All right. So let's talk about the article then that you wrote. So first of all, how did you find out kids were creating a fake positive using the lateral flow test?
Well, actually, this came about because one of my I'm quite active on Twitter, and one of the people I converse with quite a lot on Twitter, she tweeted me and said, "Hey, Mark, you've done descriptions of how lateral flow tests work in the before. What's going on with this?" And I thought, well, actually, that's a really great great answer. So she's a teacher, and she said, you know, she'd heard the reports of kids faking their lateral flow tests using orange juice and cola and other soft drinks, and asked for an explanation. And I thought, well, great opportunity. Thanks for the tip. I'll write an article for the conversation for it.
Yeah, well, and by the way, if anybody has missed that article, I'm going to put the link to the article above this video, so you'll be able to read Mark's article in full anyway after watching this video. But so I know people are going to read it, but can you talk us through though how they were able to fool the test and what's the science behind it?
Yeah, so so here you go. I've got some, like, you know, these lateral flow tests. We're probably all familiar with these things now, and they're really clever devices. Actually, there's really clever there's some really clever chemistry and chemical engineering in a way, because chemical engineering is essentially taking the chemistry, turning it into something that works practically. Yeah, and so often actually we think of chemical engineering as being these vast processing plants and so on, but you know, they don't have to be. This is a great example as well. But anyway, within these things, and you can actually open them up quite easily. There's a little tab on the end. You can open them up, and you'll find a little strip on here, and that strip is made up of something called nitrocellulose. It's a paper-like material. And if you open up one of these things that hasn't been used, what you'll notice is that underneath the S window, yeah, the first one there, you've got an absorbent pad, and then between the S window and this other second window there, here we go, that one.
Yeah.
Under here, you'll see a little pad of something that contains a sort of reddy purple material, and that reddy purple material are actually gold nanoparticles. So
right,
you might ask, well, why doesn't it look gold? It's actually because the properties of gold changes slightly when physical properties when it's that small, and it looks red when you have nanoparticles of gold. Anyway, so attached to those nanoparticles are antibodies that bind to the COVID virus. Okay,
right.
so what normally happens with this is you drop some of your sample in the S window, and it wicks up the device, and it starts to picks up the gold nanoparticles attached to the antibodies. And if there's a virus there, those antibodies also bind to the virus.
Yep.
So this all then carries on wicking up the device, and now you can imagine you've got your antibodies, and they're bound to the virus, and at this end you've got the gold nanoparticles. Okay, now as it carries on and gets to this T line, on the T line is a second set of antibodies that also binds to the virus. Okay, and those at that T line, those antibodies are immobilized, so they're stuck there. Yeah, and then as the other material flows past it, these antibodies that are stuck, they grab hold of the virus. So now, if there's virus there, you've got a antibody stuck on the nitrocellulose. You've got some virus. I need something to represent the virus. There you go, my bottle of ink. There's the virus. Okay, and then you've got a second set of antibodies that binds there, and that's all attached to the gold particle. So this is what's sometimes called a sandwich assay. So you've got the one antibody is the bottom of the sandwich, the virus is the middle of the sandwich, and the second at the top, and that immobilizes the gold nanoparticles, and that's what then appears as the red line there. Okay, and then if the material then carries on flowing up and it meets the C line, and at the C line is a third set of antibodies that binds to the first antibody with the gold. Okay, so that's a control. So that's then the first antibody, yeah, binding to the two antibodies binding together with the gold at the end, and that just tells you that the device has worked. Okay, so that's how these lateral flow tests work normally. Okay, got that? Good. Okay,
followed it.
Right, good. Now, what happens? Something weird is happening with the when you add something like the colas or the orange juice or something to this, because clearly they haven't got the virus in them, so you shouldn't expect them to produce anything really at that T line. Now, when I went and trawled the social media and so on, what I noticed is that everything that had been added, everything that seemed to produce this fake positive was mildly acidic. You know, so cola, for example, it's about pH 3 to 4, orange juice about the same, apple juice, and so on. Vimto, I think I saw as well, and that's the same. So pH 3, it's perfectly safe to drink and so on, but antibodies don't like it. Yeah,
Right.
antibodies are evolved to work at about pH 7. Yeah, and putting them at pH 3 massively disrupts them. They just don't work at that pH.
Right.
And what I suspect is happening is that the pH, the low pH, is actually partially unfolding the antibodies. Okay,
Right.
so when I talked about earlier about proteins being these really complicated molecules made of long strings that then fold up, yeah, they've got to fold to exactly the right shape to do their job. Yeah, if an antibody is going to bind the virus, it's got to be exactly that right shape, and if it's not the right shape, it doesn't bind. Okay, so I suspect what's happening is that the pH is unfolding the antibody. Now, what you might think, well, surely that would mean nothing would happen. But also, I think what's probably going on is actually some of the antibody is, as it unfolds, it means there's lots more non-specific interactions that are available to the gold particle. And so the gold, which is quite sticky in itself, just sticks directly to the unfolded antibodies. And that's what causes that fake T line there. And anyway, one of the things I did to test that hypothesis is then what I did is I took one of these devices, I added cola to it. Sure enough, I got the fake line. But then afterwards, what I did is I added buffer. These, you get these little buffer packs in here, and these are here to make. Yeah, this basically contains a solution that makes sure the pH is kept exactly right for the antibodies. And if you drop that onto the device and let that wick up over half an hour to an hour or so, that fake T line disappears. So once you return, once you return the device to the correct pH, the fake line disappears. And so that was the way I found that you could tell a faked positive test from a real one. So there we go.
That's really interesting. Thank you for the explanation. But I mean, I suppose my question to that then is that, I mean, how does this impact the possibility you're not trying to cheat, getting a false positive or negative using the test?
Sorry,
I mean, does that? So given that that's the case though with Coke, does that mean that how sure can you be or confident then can you be in the lateral flow test?
I mean, I think if they're done correctly, then a positive result almost certainly means you have you have COVID. It's not the device that's a problem. It's the user trying to manipulate it to use it. So I think the simple thing to say is, or if the people should be supervised, kids probably should be supervised when they're doing these tests to make sure that they're not dropping
I suppose the flip of it is that, is there a way to cheat the system then to hide the fact you've got COVID, or would that be impossible then, given the way it's been set?
No, actually, I think cheating it and forcing a negative result when is actually positive is much more difficult, because these, if you do anything to really disrupt the test, then the C line would disappear as well. Yeah, you wouldn't see anything on there at all. Yeah, now I mean, these things, they aren't perfect. You probably about 60% effective, so there's lots of false negatives. Yeah, but then that's that's known. It means that
that's the nature of the beast in terms of the fact that your swings and roundabouts, isn't it?
Yeah.
To get the quick effective test done, you lose something in terms of the accuracy.
It's what they sometimes call it. It's a green light test, not a red light test. So it tells you whether sorry, the other way around. It's a red light test, not a green light test. So it tells you when to stop, i.e., that you're infected, don't go and do things. It doesn't tell you that you're okay.
Right.
Yeah,
which is where a PCR test is far more effective.
It's much better. Yeah, so they're much higher degree of accuracy, because they don't detect the virus directly. They detect the genetic material in the virus, and they do that by this process, polymerase chain reactions, PCR, which massively amplifies the amount of genetic material in there. So these can only detect the virus that is there. you know, the PCR tests take the material that's there, amplify it, you know, billions of times, and then detect that, yeah, the amplified material. So they're much more sensitive, but they involve, you know, you have to be carried out in a lab and so on, and so
sure, exactly. No,
it's like,
that's brilliant. Well, no, thank you for such a thorough explanation. That's been really interesting actually going through that, and actually, like anything, it's far more easy when someone shows you than just reading it on an article as well. So it really did expand on what you said in the article. Thank you for that. So what final question, given that we are now getting close to the grand opening of the whole country, I mean, so what are your views in terms of the country coming out of lockdown? I mean, a personal view I appreciate, but what do you think? Too much too soon, or is it time really for us to be coming out?
As you say, you know, just by very much personal view, you know, and I'm taking my expert hat off now because you know, this is a public health matter, so it's purely my opinion. But I think at some point we've got to, you know, we have got to open up again. I think, you know, I've got teenage kids, and I can see what it does to them being continually isolated and locked down. So I think we do have to be opening up, you know, gradually, much more. I think, conversely, I think that, you know, things like there are simple things we could still be doing, like wearing masks. I don't understand why the guidance to be wearing those has been dropped. And honestly, you know, whilst as brilliant as the football's been, I do wonder about how sensible it is cramming 60,000 people into Wembley and then encouraging them to shout and sing for a couple of hours. Is you know, so whilst I broadly agree with that, it's, you know, it's time to start getting things going again. I do think that we still have to be sensible about it, and
I would agree with you 100% that. I mean, it's how you manage the opening up rather than just the opening up, isn't it? I suppose I think we would agree on that. It's and a gradual thing. Is that fantastic? Well, look, one final question actually. Who's going to win on Sunday? What's the score?
Oh, well, as somebody, you know, an expert of football who only ever watches it when England are in the knockout round of competitions, I'm going to be optimistic and go for 2-0 England. Yeah, so then why not? But yes, I'll be watching.
Glad to hear you. Well, I certainly hope you will win watching as well. Well, Mark, I really appreciate if people want to know more about the university and the courses, send me over the link and I'll put it above the video as well. But the link to the actual article will be above the video. So viewers, I hope you found that really interesting, because I found it interesting. You can check out the article which Mark's talk is based on, where we started this all in the first place. And if you've got any questions for Mark, feel free to put them below the videos. I'm sure I'll be delighted to get your views and what your thoughts are in terms of what he just said about the tests and in terms of the process in what he discovered as well. So Mark, thank you very much. Sorry, you could say something.
I was going to say, put them on the video. You can also tweet me as well, you know, and ask me things there as well. And always appreciate interacting with folks interested in the science.
Brilliant. Well, I appreciate it very much. Thank you very much. So good luck. Well, I think the year's finished now, isn't it? I mean, are you still teaching, or is the term finished now?
No, teaching's finished. We've just finished all the marking, getting the marks out to the students, and now we turn to planning for next year and preparing all the new material and trying to second guess what it's going to be looking like in the new year. Fingers crossed. We're planning and hoping for lots of face-to-face teaching and being able to welcome our students back onto the campus, because we have missed them.
Well, I certainly hope that's the case for you, and I hope obviously you're safe and well when you do that as well. So thank you very much, and enjoy the summer, enjoy the football, and thank you very much for taking time out to talk to me today.
All right.
Thank you. Look after
Cheers.
Thank you, viewers, for watching. I hope you found that useful. Until next time, as always, stay well and stay safe. Bye-bye.